Find the smallest value of the integer k, for which k x squared plus 7x plus 3 is supposed to be always positive for all values or for all real values of x. So this is what they want. Does this make sense to you? This is always positive for all real values of x. Okay? Now, let's look at the expression. I've got k over here, which is an unknown. I've got x over here, which is a variable. Do you know the difference? When I use these two words, unknown, variable, is there a difference?
Don't know.
Okay, variable, when you conduct experiments in chemistry, in physics, in bio, variables are something that you want to change. And you see how the result changes as you change the variable. Does that make sense to you?
Yeah.
Okay, so here I have an expression. I am allowed to substitute in any value of x I like. When I substitute different values of x, I will result in different values, right? Usually we say let fx be equals to this, right? So for different values of x, I will get a different result. Okay, so that is a variable. Now, normally we have things like this. Fx equals to maybe 3x squared plus 7x plus 3, for example. So I only have one variable, which is x. X can change. And it will have a value. It can be more than 0, it can be less than 0, it can be equal to 0. These are the only three possible cases, isn't it? Okay, now, there is a certain value of k over here. K is an unknown. Okay, k is an unknown, it is an integer. Do you agree that as k changes, k could be, earlier I said 3, it may very well be 100, it could be a negative value, I do not know. K has a certain value. And the value of k is going to determine whether my fx is going to be greater than 0, less than 0, or equal to 0. Do you agree? Make sense? Depending on what the value of k is, depending on what you're substituting for x, isn't it? Okay, so this is the question, the expression. And now they say that this will always be greater than 0. Does that make sense to you? Is there really something like this where we have kx squared plus 7x plus 3? No matter what you sub in for x can be anything in the world. No matter what you sub in, it will be greater than 0. Does this sound possible to you?
Yes.
Okay. Now I draw my x-axis. Alright? Now I would like to express this as y equals to. Y equals to this expression. For this expression to always be greater than 0, I am saying that y is greater than 0. Does that make sense?
Yes.
Okay, so I want a graph that y is always greater than 0, no matter what the value of x is.
Above the line.
So you are seeing it, okay? Let me scaffold a little bit more for you. What is the shape of the graph?
Parabola.
Parabola. Opening up or down?
Up.
Why are you so sure it's up?
Positive.
What is positive? Did they say the coefficient of x squared is positive? Where? What is always positive? The y in this case is always positive, right? Does that therefore mean it is a parabola opening outwards?
Yes.
Oh, okay. So now the question is it a parabola opening up or down? And it sounds like you are saying that it must be a parabola opening upwards in order to result in y being always positive. Is it? Is that what you're saying?
Yes.
How about like this?
No.
So is this the shape? Is this the graph that I want?
Yes. Wait, the shape that you want, but not the graph that you want.
Okay, what's wrong with this now?
The x-axis is touching.
Touches the below part of the x-axis.
So you see, this is my positive y value, right? This one over here is y equals to 0, and this portion is y less than 0, or y is negative, right? I only want y to be positive, so I cannot have a graph like this. How about like this?
No.
Okay, how about like this?
Yes.
Is this the only case?
Yes.
No? Then what other cases can we have?
Can be closer.
Okay, so something like that? Okay, so generally all these I refer to them as the same. Basically, I have a parabola opening upwards that is above the x-axis. Now, take a close look at this. For any value of x, it's not opening upwards forever and ever. So I have a whole range of values of x. It can be negative, it can be positive, right? It can be very, very small negative, it can be very, very big negative number, positive number. For all these values of x, all my y values are greater than 0. Correct? What happens if I want a case of... What if I want to draw a parabola opening downwards? How about like this? Is this a parabola that is always above the x-axis? Why not? Because the parabola always opens forever and ever. Okay? When you sketch your graph, parabolas, if they are going to cut the x-axis, you better make sure they cut. Okay? And parabolas will always cut the y-axis. Always cut the y-axis. Because it always opens upwards, it always opens downwards. Confirm will cut the y-axis one. Okay? What if I want to change the question? Let's say I want this to always be less than 0. What do you think is the shape of the graph now? Okay, this means that it will open downwards. What else? Below the x-axis. What other clues can you get from here? What is the range of value of k now? For this case, k must be less than 0, right? Right? So that is a parabola opening downwards. Okay, let's go back to the original question. Don't confuse you too much. This is the original question. They say that yeah, it has to be always positive. So I know that first clue, k is greater than 0. Why? You don't need to explain why, but I need to know that you know why. Why is k more than 0? Okay, what does k represent? K is the coefficient of x squared. When the coefficient of x squared is more than 0, I get a parabola opening upwards. Alright? So that is the first thing that I can have. Next thing. But this is not the answer. This is not the final answer yet. Okay, because simply with k greater than 0, I can have a graph that looks like this. Right? For this one also, k greater than 0, isn't it? Yes. But it is not the case that I want. So I have more conditions to meet. What is the other condition?
Positive.
What is positive?
Y.
Okay, y is positive, y is greater than 0. Tell me about the intersection with the x-axis over here. Never touch. What does that imply? No real roots. Excellent. So this tells us that at the back of our minds, we must be thinking, okay, no real roots. Okay, what does this mean now?
No solution.
Okay, no solution, no solution. What does this mean? Discriminant is less than 0. This is what is going through your mind. Okay? So discriminant. Can you tell me what's the discriminant now?
A squared. Wait.
Tell me the values. Don't tell me b square minus 4ac. 7 square minus 4k 3, and this is less than 0. Okay? So we've got 49 minus 12k less than 0. Huh? 37? What are you talking about? Okay, so over here we've got negative 12k less than negative 49. Make sense? So k is now 49 over 12. What is the missing inequality? More than. K is more than 49 over 12. What else do we have? K is supposed to be more than 0. K is supposed to be more than 49 over 12. So which answer do I use? So which one do I use? Okay, so how do we combine these two values? Okay, let's take a look. Both of them must satisfy at the same time, right? Die must have k more than 0. Am I right? Yes. Die must have k more than 49 over 12 also. Am I right? They must come together. How do I combine them together? I'll draw a number line. This is a k number line. Okay, I put in the value 0 over here, and I put in 49 over 12. Now, k more than 0 is represented by this arrow. Am I right? So anything along this arrow will work. But I've got another condition. It is k more than 49 over 12. Am I right? I want both of them to be satisfied at the same time. I will show you 3 regions. This is one region. This is another region. and I've got a third region. Which region do I have both conditions satisfied? Yellow, green, or blue? Blue. So what is the final answer? The final answer is that K has to be more than 49 over 12, which happens to be this answer. Now they want the smallest possible value of K, an integer. So K smallest, K equals to, how much is this? 5. Okay? Now what this means is that when you substitute K equals to 5 inside here, change this to 5. When you substitute K equals to 5 over here, no matter what value of X you put in, can be negative 1 million, 1 million, anything you like, confirm the answer is greater than 0. That is what it means. Okay? Try it. Try and convince yourself. Oh, you got the answer really quickly, yeah? You get the thinking behind it really quickly. Very good, very good. But for the rest of you, just go ahead and try any value of X you like. As long as K equals to 5. In fact, as long as K is bigger than 49 over 12. You can use slightly more than 49 over 12 if you like to. And then you substitute any value of X. You will have the expression more than 0. Okay, so that's what it means. Can? Ready to try yourself? They wanted a smallest integer. Okay, so read the question carefully, yeah? Okay, so your turn. Practice now. Practice now 15 question 1. No. Let's try practice now 16 question 1. Practice now 16 question 1. You are given 5 minutes for this. We will stop at 10:54. Okay, coefficient x squared is -5. What kind of parabola are we expecting? Opening downwards. Is it possible to have a parabola like this such that the values, the results will always be negative? Where is the x-axis? Okay, it must look like this. So you see, it does not intersect my x-axis, it does not cut my x-axis, it does not touch my x-axis, therefore there is no solution if I am trying to solve for -5x squared plus 7x minus k equals to 0. If I try to solve for this, there is no solution. Okay, as shown by no points of intersection. Okay, so now what can you tell me about the discriminant? Discriminant is less than 0. Why is it less than 0? Because no real roots. It does not touch, it does not intersect my x-axis. So discriminant is given by 7 squared minus 4 times of -5 times -k. And this is supposed to be less than 0. Okay, so continue. 49 minus 20k less than 0. 20k is greater than 49. K is greater than 49 over 20. So smallest, k equals to 3. Is that the correct answer? Okay, then you got it already. Did I ask you to find x? No, they didn't ask you to find x. No, not all negative values of x, for all real values of x. So x can be anything, positive, negative, decimal, irrational, rational, not anything. Okay, I want you to take a look at work example 15 and what you have just done. Look at the two questions. What's the difference between these two questions besides the expression being different? Parabola opening up, parabola opening down. What else did they say? They want the expression to always be, in work example 15, always be what? Positive. In practice now 16, they want it to be always? Okay, one more time. In work example 15, they want it to be always? Positive. In practice now 16, they want it to be always? Negative. And what was your approach for the discriminant?
Same.
Discriminant is less than 0. I hope you're all listening clearly, because some people think that, oh, in work example 15, if I want it to be always positive, guess what they do? They let the discriminant be more than 0. Then it's wrong. When discriminant is more than 0, it means there are two real roots. When I want it to be always positive, can there ever be roots? Cannot. No roots, which means the discriminant is less than 0. Okay, so in summary, what I want to say to you over here is that when ax squared plus bx plus c always greater than 0, this tells me that discriminant is less than 0. Case number 2, when ax squared plus bx plus c always less than 0, let me rewrite it. This always greater than 0, this one is always less than 0. This tells me that discriminant is again less than 0. Can? Two different cases, the condition is still the same. Discriminant less than 0. Alright? Now next.
So must we draw the graph?
You don't have to.